Hi Math 10Cs. Our first unit is polynomials, so I would like to start with the very first lesson, adding and subtracting polynomial expressions. I just want to review quickly, it says parts of an equation. Here we have an equation that says 4x minus 7 equals 5, right down here. Let's just look at the parts. I want to make sure that we're using the correct terminology, and I just want to review that terminology with you. A variable is a symbol for a number we don't know yet. It is usually a letter like x or y. So here's our variable, x, okay? A number on its own is called a constant. So here this -7, that's a constant, or so is 5 a constant. And the reason is because those do not have variables. They cannot change, okay? A variable can, of course, vary depending on what the value is. A constant stays the same. A coefficient is the term we use for the number in front of the variable. So in this case, 4 is my coefficient, okay? And of course, 4x, if I say 4x, that means 4 times x, or 4x, or just 4x. Okay, and the reason we don't write the times sign, probably you know, is because if we wrote 4 times x, that just gets complicated and weird looking, right? So we just don't write it like that. We just write it 4 beside the x, but we know that means multiply. An operator is a symbol such as plus, minus, times, divide that represents an equation you want to do something with the values. That represents in an equation, I guess. So for example here, this is minus, that's an operation, okay? Equals, that indicates that this is an equation and both sides are equal. A term, okay, all of these are terms. Another word for sort of a variable can be a term. -7 is a term and 5 is a term. Terms are usually separated by plus or minus signs, okay? And given that this has an equal sign, this is also an equation, okay? Equations have equal signs. Expressions do not, okay? An equation, the whole thing is called an equation with their equal sign, but just a single side is called an expression. Okay, so when I think about algebra, let's just think about this for a quick moment. And I know this is something you would have done in like grade 7, 8, 9. If I said something like, I've got 3 boxes on one side of a fulcrum. Fulcrum is like a balance beam. Okay, I've got a fulcrum, and this is sort of like my equal sign, okay? That's a balance beam. We know that from science. That's called a fulcrum. That's sort of just the middle. So let's just make that a little bit bigger. And because this is a balance beam and this is an equation, then this has to be equal. So I'm just going to write a little equal sign in the fulcrum. If I said to you, I've got 9 marbles over here, and I've got 3 boxes over here, well, how many marbles would go into each box if this has to be equal? The boxes basically have no weight, but I know then, therefore, that I would have 3, 6, and 9. I would have 3 marbles in each box. Does that make sense? So what that is, that's basically algebra. What we just did there is we said, I've got 9 marbles, and that's equal to 3x. And I divided both sides by 3, right? We divided those by 3, and in each box was 3 marbles. So x, when we're doing algebra, is just basically, when we're solving an equation in algebra, is basically what is in the box. What's in the x, okay? We can do other ones where, let's just do one more here. If I say, well, here's another fulcrum. Let's put the boxes on this side, okay? And let's do okay, I've got 16 marbles over here. Oh, but let's just do this. Let's add 4 marbles over here. Okay, now I've got 4 marbles over here, 16 over here. How many marbles could I take away from both sides to begin with? Well, I could take away 4. I know I can take away for sure 4 marbles from this side. And then in these magical boxes, I still don't know what I've got. So what do I have left in these boxes? Well, I'm going to divide these remaining marbles by 4 because I have 4 boxes. So what was the equation? And I know that in each box it has to be 3 again. Okay? Let's maybe not do them in red. Let's just do them in orange since we chose orange here. Since I chose orange to begin with. Okay, I got 3 marbles, 3 marbles, 3 marbles, and 3 marbles. And if we were to look at this equation, we just did 4x plus 4 boxes plus 4 marbles is equal to 16 marbles. Okay? I'm literally losing my marbles, people. Just joking, okay? I've been waiting to use that joke. So, what did we do? So we subtracted 4 marbles from both sides, and we got 4 boxes were left, right? Those marbles are gone. We're left with the 4 boxes, and that's 12 marbles, and we divided both sides by 4, and x was 3. In each box is 3 marbles. So that's the basics of algebra. So when I say 4x plus 4, I know that cannot be 8x. 4x plus 4 cannot be 8. 4x plus 4 cannot be, 8 plus x. None of those are correct, right? Because I know a box is a box, a marble's a number, and a box is the x. So I can't put those together, right? I can't say a box plus a marble is equal to 2 boxes or 2 marbles, right? None of those are correct, okay? A box and a marble is a box and a marble, okay? Separate. All right. So let's look at polynomials. A polynomial, you've looked at a little bit of this, I know, in grade 9, but an example of a polynomial is that we can have constants, okay? Here's a -2 constant, x or x squared, those are my variables, okay? And we can have exponents. We've got here an exponent of 2. Here's our exponent of 2. And over here, there's a little invisible exponent of 1. Okay? They cannot be they can be combined using addition, subtraction, and multiplication, but not division. So if I look at this, this is not a polynomial, and nor is this. But this is indeed a polynomial. When we've got a bunch of plus or minus signs in between some numbers, either by themselves or with variables, and with exponents that are whole numbers. Okay? What's a whole number? No decimal. Okay? Now whole number exponents only. Okay? Polynomials can be classified according to the number of terms it has or according to its degree. So let's just have a look. If I want to classify these polynomials according to the number of terms, this is a single term. It's called a monomial. A double term, 2 terms, is called a binomial. And 3 terms, 1, 2, 3, is called a trinomial. So look at this example. It says, consider the following. In each case, state whether the expression is a polynomial or not. If it does not represent a polynomial, explain why. If the expression does represent a polynomial, state whether the polynomial is a monomial, binomial, or a trinomial. This indeed, the first one, is a yes, and this is a trinomial. Okay? This next one here, this is a no. Okay, this is a no, and that's because we cannot have, no radical over a variable. Okay, that's not allowed. Okay, if I look at this one, this is a yes, and this is a monomial. Now, how can this be a yes when this was a no? The reason is because the radical, it's okay, the radical is only over the coefficient. Okay, and look at the next one here. If we look at this one, this is definitely a no. Whoops, because we are not allowed no. Oh, sorry, this is a yes. What am I saying? Hold on. I was thinking that was a variable for a second. If we look over here, this 1/2, 0.5, which is 1/2 is a fraction. This is a no, okay? Because no fractional exponents, right? Whole number exponents only. Whole number exponents only, okay? And old Mrs. Schwartz, I just looked at this so quickly. Now, 64 to the power of 1/2, if you plug that into your calculator, you're going to get 8. So that's just 8w squared minus w. And we know that's okay. Okay, and that's a binomial. And that was a yes, I guess. Let's just write yes, not okay. Okay, that's a yes, and that's a binomial. All right, the next one here, that's definitely a no. No division allowed. And this next one, probably some of you are thinking right away, that's a no, because we need whole number exponents only, and these are integers, okay? Whole numbers, remember, start at 0, 1, 2, 3, on to infinity, okay? Integers have negatives, so no integer exponents. Whole number exponents only, right? Watch this. There we go. Same thing. Okay, let's look at the next one. Pi r squared. That's actually a yes. That actually is a monomial. Because even though there's a pi in it, pi is just a number, okay? It's okay. It's a coefficient, right? The coefficient can be anything, right? That's just like this one over here. The root 12 is just the coefficient, okay? The coefficient, radical coefficient is okay, okay? So just so we can see all the different types. And then, of course, r is a variable, okay? This is a no radical variables. Okay, and let's see here. Oh, 10 to the power of x, okay? No variable exponents. This is actually called an exponential function, not a polynomial, okay? That's not a polynomial. Okay. Let's take a look at a degree of a polynomial. So the degree of a polynomial, if I look at this polynomial over here, this is a trinomial. The degree here, this is a 4, okay? The degree is the value of the exponent, okay? And this exponent here would be a value of 1. So this is a polynomial with 3 terms. We would say that the degree of this polynomial, the overall degree, the degree of this term was 4, the degree of this term is 1, and the degree of this constant we say is 0. And the reason for that is because we can think of that as x to the power of 0. And anything to the power of 0, if you remember from grade 9, is equal to 1. So therefore, this is just really equal to 1. But we can kind of think of it in terms of having a variable to the power with a degree of 0. So the degree of this overall polynomial, though, is the term with the highest degree. So who's the boss of this polynomial? It's the 4. So we're going to say the degree of this polynomial is 4. Same with this one. If I look at the next one, for a polynomial with 1 degree variable like x, the degree is the largest exponent of that variable. So for example, 4x cubed, the degree is 3. Even though this is a 2 and this is an x to the 0, the degree of this polynomial is a 3. He's kind of the boss. Okay? This degree is 1. The degree here is 3, the one with the highest exponent. The degree of this one would be 5. Okay? This would be a degree of 5. And the leading coefficient, the number in front of the variable with the highest degree, is called the leading coefficient. The leading coefficient here would be 4. The leading coefficient in this last one would be 2. Okay? So just a little term, I don't think it says that anywhere, but this is the leading coefficient. Okay? And those are the numbers in front of the variable with the highest degree. If we were to write these, usually you would write something like this last one as 2x to the 5 plus x squared minus x in descending degree order, right? We're starting with our highest degree and writing with the lowest. Okay, when you know the degree, you can also give it a name. A constant, okay, has a degree of 0. Okay, a linear function has a degree of 1. A quadratic function has a degree of 2. A cubic function and a quartic function. Okay, those are, we don't really have to know all of those the words this year, but I would say for sure you could get familiar with constant and linear. Okay, we're going to know those by the end of the year. Degree of a polynomial with more than one variable. If there is more than one variable, you need to look at each term. Terms are separated by plus or minus signs. So similarly, this is a degree of 1 plus 2. This is a degree of 3. This next term has a degree of 1. And this one has a degree of 0, right? Because of that constant. All right, and this is still the polynomial. The degree of this polynomial would be 3. He's the boss. Okay? So to find the degree, you add the exponents of each individual term, right? This is a 3, and this is a 1, and this is a 3, and this is a 0. Now keep in mind here, it's the degree with the highest, the term with the highest degree is the boss, is the degree of the overall polynomial. So there's the degree of the individual term, which we've done. All of these individual terms are up here. And then the degree of the polynomial is going to be 3. Okay, there's actually 2 degrees of 3, and they're tie. So the largest degree is 3, so the polynomial we say would have a degree of 3. And that doesn't mean so much in grade 10, but when you get into higher levels, you can tell what a function looks like. You kind of get an idea of what a function looks like and how it's going to act according to its degree. Okay? Look at this next one. Why don't I let you guys have a try at this? Do you want to try this? Why don't we try this? I'm going to pause the video, and I'll give you a second. Why don't you state the degree of the following polynomials and classify them according to their number of terms. Okay? Do you want to try? I'll give you 5 seconds here to pause the video and you give it a try yourself. All right, let's look at the first one here. We've got x, y, z. If you've done this, that's great. This would be a degree of 3. Okay, state the degree and then classify them. And this is also a monomial, okay, because it's just a single term. All the variables are attached by multiplication, so that's a single term. This 25x cubed, y cubed, z cubed, this one might be a little tricky to figure out the degree actually. This is 25 cubed times x cubed times y cubed times z cubed. And the reason is because this 3 applies to every single thing inside those brackets. Sort of just a simplified way of writing this, right? We just write it in brackets with a single sort of degree there, okay? Now I know that 25 times 25 is 625. Times 25 is a big number. This is equal to 15,625, right? 25 times 25 times 25. Okay, and then that's x cubed, y cubed, z cubed. So this degree here, the degree would be 9, right? Because we're just going to add up all these 3 degrees. And the polynomial is a monomial. Okay, it's still just a single term, quite big numbers, but it's still just a single term. Let's look at the next one. This is a 1, 1, 1, a 1, and a 1. So the degree here would be 3, 1, and 3. And so our overall degree is a 3. And this is a trinomial. Okay, let's look at the next one here. Here's a little y to the power of 1. Here's a little z to the power of 1. So I'm going to fill in those missing exponents just so I can readily see them. Okay, so the degree here, this guy would be a 6. And this guy would be a 6. And the one in the middle here, hopefully you remember this. This is y to the power of 4, which is y times y times y times y. And if I take that and then I square it, I get y times 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 y. So that's y to the power of 8 altogether. So the degree of this trinomial would be 8, and of course, that's a trinomial, isn't it? Okay, the next one, the degree is 2, because this is a 2 and a 1 and a 0, and that's a monomial. And the last one here, the degree is 0, and that's again, oh, I wrote monomial, that's a trinomial. That's 3 terms. Sorry. Sometimes I look ahead. Oops, monomial, and it would help if I could spell. Let's try spelling this. There we go, monomial. Okay. So hopefully you understood that and followed along nicely. Let's look at combining like terms. This is the last big concept. This is a pretty long first lesson, but I think a lot of this is somewhat review from grade 9. Let's look at some like terms. Like terms are terms that have the same variables to the same degree. So for example, 3x squared and negative 4x squared are the same variables with the same degree. Those are like terms. X and x squared would not be, okay, those are not like terms, right? They don't have the same variable. They don't have the same exponent, rather, okay? So if we look down below, and then something like this, negative 2x squared y cubed, x squared y cubed, same variables with same degrees, so those are like terms. Okay, simplify, state the degree, and classify. So let's simplify to begin with. Let's look at what are my like terms. Here I've got a 4x and a negative 2x. So if I were to think about Lego, I might call these guys here, I might call these my x blocks, okay? And then I might call these guys here my y blocks. So those are totally different shapes. So I can't say that 4x plus 3y is 7xy. No, because I've got 4x blocks. Okay, I'm going to start with 4x blocks. I just give 2 away to Tommy. So 4 minus 2, I'm left with 2x blocks. And I'm keeping my 3y blocks. Okay, so I've simplified. The degree of this binomial is 1, because I've got a 1 here and a 1 here. The degrees are just 1. Those exponents are just 1. And this is a binomial. Okay, let's look at the next one. Again, I'm going to think of this. These are my x squared blocks. Let's pretend. Or my a squared blocks. These are a squared, say. And these are my a blocks. Totally not the same. Okay, so I can't say that a squared plus a is 2a squared or 2a or anything like that. I'm going to combine my a squareds separately from my a blocks. Okay, I've got a really neat collection of Lego. And if I can, we want to try to put an equal sign down below. What that just basically means is when we're simplifying is this next row is equivalent to that above, okay? 6a squared plus 2a squared, well, that's 8a squared. And I gave away 4 of my a's, but I kept 6. So if I bought 6 and gave away 4, then I'm up 2 a's, okay? And of course, the degree here is 2 because my highest degree here is 2, okay? That's a 2 and that's a 1. And what else? That's a binomial. All right. Now the next one looks a little bit daunting because there's so many terms there. But if we just break it down, let's do our a squared b's, okay? 4a squared b And, ooh, negative 3ba squared. This is actually another like term with those 4a squared b, isn't it? Because we know that 2 times 3 is the same as 3 times 2. So with multiply, I can move this a and b around and put b before a squared. I can put the a squared b or ba squared, and those are the same things. Okay, so I've got 4 minus 3 is 1 a squared b. Okay, I can write a 1 or I can just leave that blank. All right, and then I've got 2ab squared and 2b squared a, which is the same thing. Oh, hold on a second here. That was a negative and a positive. So what's going to happen here? That negative 2ab squared and the positive 2b squared a, which is the same as ab squared, those are opposite integers. Those are just going to cancel, aren't they? And now the last thing I'm left with is this a squared b squared. So I'm going to rewrite him as a squared b squared. And we would write these in descending order. So I almost should write the a squared b squared first plus the a squared b second, because the degree of this one is 4, right? The degree of this one is 3. So my overall degree is 4, and that's a binomial. All right, and remember, you don't have to put the ones in front. They're there, they're invisible. That's a 1, and that's a 1. Okay, 4a minus 6a. These brackets here, let's just review this really quick. This is just saying I've got a trinomial plus a trinomial. The brackets don't mean much here because this is a plus sign. Okay, make sure you recognize that we're just adding. We're adding two trinomials. So if I look at these, let's just go ahead and I've got 4a and I've got a minus 6a. That's going to be a negative 2a. Okay, and in negative 2b, I'm going to choose another color here. Let's choose one I haven't used. Let's try pink. Negative 2b and 4b, of course, that's going to be a positive 2b, right? Negative 2 plus 4. And then positive 1c and negative 3c, that's a minus 2c. All right, so we've got, what's our degree there? Our degree there is 1, because all of these have exponents of 1, and that's a trinomial. Okay, last couple of examples here. Simplify, state the degree, and classify. These ones are a little trickier because we've got this minus sign. So what I want to do is, let's explain a way that we can not have to worry about the distribution of that quite so quickly, so in a confused manner. So when I see a minus sign, I'm going to rewrite my second polynomial. I'm going to change that to a plus sign, and then everything in front of, in the brackets, I'm going to change the sign to. This was a 2x squared. Now I'm going to make it a negative. This was a negative minus 4x. Now I'm going to make it a positive. This was a plus 2. Now I'm going to make it a negative 2. Okay, let's make that guy a negative. So all of the signs in the brackets changed, right? This was a positive. It becomes a minus. Minus becomes plus. And now let's combine these like terms. 4x squared minus 2x squared is 2x squared. Negative 2x plus 4x plus 2x. And 3 minus 2 is plus 1. Okay? The degree is 2, and this is a trinomial. All right, let's look at the next one. Just sort of separate this a little bit. So again, there's a minus sign here. I'm going to rewrite this as 6y minus 2x plus z. The first trinomial doesn't change, of course. I'm going to change this to a plus, and everything inside is going to become the opposite sign. The 3x becomes minus 3x. I'm going to get a plus 5 and a plus 5y and plus 2z. So let's just rewrite those. We've got a minus 3x plus 5y and plus 2z. All right, let's combine those now because it's just plus, right? I'm going to go x, y, z, negative 2x minus 3x. I lost 2 x's and I lost 3 x's, or I threw away 2 x's and I threw away 3. I've thrown away 5 x's altogether. our y's, and sometimes I will literally circle these just so I don't forget or check them off, right? I'll go like this because it's pretty easy to miss a term, but that's a plus 11y. And then our z's, right? We've got 1z and 2z's, so altogether that is 3z's. All right, and again, our degree here is 1 because these are all degrees of 1, exponents of 1, and this is a trinomial. Okay, last one here. I guess it's not quite the last one, but almost. If I look at these minus signs here, okay, this minus sign here, again, when it's in front of the brackets, that means I have to rewrite this. I'm going to rewrite this with a plus, and I'm going to rewrite this with a plus, and everything inside the brackets is going to change. Nothing previous, though. This is still an a minus b, and that's a plus negative 3a plus 2b plus negative 6a plus 5b. Okay, everything inside change. That becomes negative, that becomes positive. This becomes negative, this becomes positive. So let's look at the next row. We've got a 1a minus 3a's minus 6a. So 1 minus 3, negative 2 minus 6, negative 8a's. And then a negative b. Again, let's use a different color. That's a negative b, positive 2b, plus 5b. So I think it's easy to go 5 plus 2 is 7, minus 1 is plus 6b. So there's our polynomial simplified. Our degree is 1, and this is a binomial. Oops. Okay, that's a binomial. Let's look at the next example. It says a rectangle has a length of 4x squared plus 2x plus 1 and a width of 3x plus 4. What is the perimeter of the rectangle? So I know you guys have been working with perimeter for many years, and I also know that you probably are quite remembering a perimeter of a rectangle. So our length, they're saying that the length here is 4x plus 2x squared plus 1. And this would also, and I could probably write that as 2x squared plus 4x plus 1. I often in descending order, okay? And I know if this is 2x squared plus 4x plus 1, this top line is also, right? Those would be equivalent because it's a rectangle. And we could probably write a little square in there just indicating it's a right angle. And if this width, therefore 3x plus 4 would be equal to the other width. If I want the perimeter, I could just use my perimeter formula. Right, we know our perimeter is 2 length plus 2 width. So perimeter is 2 times 2x squared plus 4x plus 1 plus 2 times 3x plus 4. And if I distribute that 2, right, we're going to multiply that 2 through. Okay, and we get 4x squared plus 8x plus 2 plus 6x plus 8. And of course, combining our like terms, 10x squared plus 8x plus 2 plus 8, that's plus 10. Okay, so there's a simplified expression for our perimeter, simplified equation, I guess we could say. And if x is equal to 2, what is the perimeter of the rectangle? So now, if x is 2, then our perimeter is going to be 10 times 2 squared plus 8 times 2 plus 10. We're just going to substitute in x equals 2. And remember bed mass. How do we simplify this expression here on the right? This 10 times 2 squared is 10 times 4, which is 40. Okay, sometimes students want to try to do 10 times 2, which is 20, and 20 squared, which is 200. No, we have to do our exponents, right? We have to simplify our exponents before we multiply. Okay, multiply comes second. So this is 10 times 2, all 2 squared. So that's 10 times 4 plus 16 plus 10, which is, of course, 40 plus 16 plus 10, which is 66. And I guess is this centimeters? It doesn't really say the units, does it? So let's just say it's 66 units in length. Okay, and then the last one, the perimeter of a rectangle is, okay, we've got a perimeter, we've got a rectangle, sorry, we've got a triangle, I should say. The perimeter of the actual triangle is 8x minus 2. Okay, so I'm just going to rewrite this, sorry. Our perimeter is 8x minus 2. That's the actual perimeter. I know that's the outside. And it says two sides are 2x plus 3 and 3x minus 1. So what's this guy over here? What's the length of the third side? Well, I can take that perimeter and I know that it's side 1 plus side 2 plus side 3. So if my perimeter is 8x minus 2, and side 1 is 2x plus 3, and side 2 is 3x minus 1, then I want to find side 3. Okay, how do I do that? Well, let's simplify it. We can simplify our right-hand side. I've got 2x and 3x, that's 5x, and 3 minus 1 is 2. If I want to find that third side, I need to isolate this third side, so I'm going to move over my 5x, or subtract 5x. I always say when I move it over, the sign changes, so that's going to become a minus 5x, and I'm going to subtract 2 as well. So I've got a minus 2 here. So now I've got an 8x minus 5x, that's a 3x, and a negative 2 minus 2 is a negative 4. And that's my side 3. Okay, a little bit nonsensical because it's a variable, but there we go. That's our very first lesson, and our assignment for that first lesson, if we look back here really quickly, our assignment for the first lesson that I gave in class was questions 1, all of 1, number 2, and number 3, 4, 5, 6. Okay, if it gets a little repetitive there for number 2, you could just do odds, but I think I did 1, 2 odds, 3, 4, 5, 6. Okay. And 3 to 6. So I would try those. Make sure you're correcting your answers at the back of the book. Okay, checking your answers with the back. That's the only way you really know if you're doing things right, is by double checking your answers. And if you're getting something wrong, you can try to figure it out by looking at the answer, or if you still can't figure it out after you've done that, then you can contact me and ask me. Okay, or ask me in class. Thank you, and have a great day.